Oh, did I introduced you to my favorite student last class, didn't I? Good old Anne. Good old Anne Serkey. She gets everything right. I have two favorite students. I either use Anne Serkey or sometimes I'll use good old Ima. Ima Chekhov. Depends if I'm going to mark the assignment or just check it off, right? Ima Chekhov. Aha! Okay, here we go. Trevor will get it eventually. Approximately how many elements have been discovered? Okay. I think it's, I'm going off the top of my head, 92 occur naturally in the universe, and the remaining ones we've force-fed, we've made in particle accelerators. They last for a very short time. Some of them only last literally for like trillionths of a second before they decay into smaller elements. So 120 elements out there. I think I did my little rant about Iron Man 2 was wrong. In Iron Man 2, Tony Stark finds a missing element, and that's how he's able to replace the palladium or whatever it is in his oh, garbage science. The rest of Iron Man, by the way, if we could build an energy source that was that strong and that small, most of the physics of that suit we could do easily. It's just we can't build an energy source that small with that much power. Do that, we're good. Name two metals that are not silver colored. Well, first of all, that's not a metal. Oh, sulfur's not a metal. So I've already made it B and C just by crossing out stuff that weren't metals. And if I haven't taught you already, for multiple choice questions, a great strategy is to use a process of elimination. Not silver colored. Is gold silver colored? No. Then you know what? I don't think it's that. Oh, wait a minute, wait a minute, wait a minute, wait a minute. Chlorine's not a metal either. You know, without even knowing that, first of all, I picked easy metals. Hopefully you know that copper, what color would we call copper? Ironically, I think we would call copper colored. We've actually named a color after it. And what color would we call gold? Gold colored. I picked two nice ones. Which ones are silver colored? Pick the obvious one. Which ones are silver colored? Pick the obvious one. Silver. Yes. The alkalines, those ones there, the ones that I showed you in the first column, remember I showed you the video, you saw when he cut them with a knife, they were silver colored, but they tarnished very, very quickly. They reacted with oxygen very, very quickly. Okay. Which of the following is a metalloid? Well, sodium's a metal, strontium's a metal, sulfur's a non-metal. I think it's silicon, which is why it's a semiconductor. Semi means half and half. It's sometimes a conductor, like a metal. Sometimes it's a non-conductor. It's why we use it in computer chips. It allowed us to build little tiny on-off switches. What is a period in the periodic table? That's a period. That's a period. That's a period. That's a period. It's a horizontal row. By the way, what do I call the vertical columns? Families. Yay, we have families. Why are they set up that way? We'll talk about that. What do the noble gases He and Kr have in common? Same number of electrons? No, because helium has 2 electrons and krypton has whatever its atomic number is. Same number of valence electrons. Helium has 2. Krypton has, I think, 18, so no. Filled valence energy, ooh, maybe C. Let's look at D. Both gases will make a balloon tend to float. You may recall I actually showed you a video and we saw helium went up, but krypton, a balloon filled with krypton, dropped like it was a soccer ball. They have a filled valence energy level. They have a filled outer electron shell. There's no more room. And that's why they're so stable. It's all about the electron, silly. Number 6. Okay. How is the periodic table arranged? Huh? By atomic mass? In other words, do the atomic masses get bigger? Usually, but if you had a clever teacher, he would have actually showed you that there was one element when you moved to the right, all of a sudden the atomic mass got smaller. So actually, Josh, it doesn't quite work that way. I can cross that one out. By ion charge and atomic mass, I just said it's not by atomic mass. By ion charge and atomic number, by atomic number and chemical properties. The answer here is D. It goes up by atomic number. But Trevor, the reason that the rows, so Trevor's all disappointed. He made a mistake. Of course, you can always redo the quiz. Look up for a second, Trev, my friend. Let me get my periodic table. Let me close this, and let me zoom in to, like, come here. 150. The reason potassium is right here below sodium, the reason we didn't just put potassium right here after element 18, because you may have wondered, why didn't we just do that? It's because sodium, potassium, rubidium, cesium, they have similar chemical properties. They have the same number of valence electrons. They look the same. So that's why it's organized the way it is. Also, the ion charge, you'll notice, well, because here's an ion charge of 2, here's 2. Well, it sort of gets bigger, but then it gets smaller again. I don't know. Turn the page. A nitrogen atom is formed an ion. Which of the following statements is correct? Nitrogen. There it is. Nitrogen could either lose 1, 2, 3, 4, 5, or it could gain 1, 2, 3. Nonmetals will gain electrons. Now, when you gain electrons, you're gaining negatives. When you gain 3 negatives, that's why that ion charge is 3 negatives. So let's go look at the question. It's not going to lose electrons. It's not going to lose electrons. It's going to gain electrons, and that's going to give it a charge of 3 negative, not 3 plus. That little statement right there, Mason, actually explains a big chunk of how everything in the universe is put together. Which phrase is correct for a Bohr model of a metal ion? A metal ion, a metal ion. So if you're a metal ion and you're an ion, not a neutral atom, so if you're a neutral atom, same number of protons and electrons. If you're an ion, metals, do they lose electrons or gain electrons? They lose, so they'll have fewer electrons than protons. Let's go see what my options are. More protons? No. Oh, sorry. More protons? Yes, that works. More electrons? No. Equal? No. Equal? No. It's A, yes? Okay. Which best describes the alkaline earth metal family? The alkaline is column number 2. Family of metals that is magnetic? I don't know. Maybe. Family of metals used to make coins. I know this one is wrong because what's our 5-cent coin called? Nickel. What do you think nickel's made out of? Captain Obvious. Is nickel in the alkaline column number 2? So that's no. Is it the most reactive family? Matt knows what's the most reactive metal family. Column 1. He's watched me blow stuff up in the video, so it ain't that. So it's A or it's D. Oh, you know what? D, because in column 2, everything has 2 valence electrons. D is the best answer. Which then I would say, I guess they're not all magnetic. And they aren't. Iron is magnetic, and some of the ones in the middle, if you take quantum physics in second-year university, you'll learn why that's the case. A scandium element, element number 21. Mr. Duick, you said we weren't going to go past calcium. I lied. We're going 1 past calcium. Has formed an ion. Which of the following statements is correct? You know what? I think it's lost 3 electrons, but that would give it a charge of 3 plus. I think B is correct. Looking at where it is, I'm looking behind you at the period. Looking at where it is on the periodic table, yeah, it would lose 3 electrons. Oh yeah, there it is, a charge of 3 plus. Things start to go weird right in this column. This is when we say ions become multivalent. They can have this titanium can lose 4 electrons and be happy. Actually, it can also lose 3 electrons and still have 1 extra, and it can still be content that way. It depends how the electrons are arranged. The shells start to overlap and get entangled. You don't need to know that yet. Match the descriptor. A family with 1 valence electron, very reactive. Oh, Matt likes that. It's the alkali metals. The number of protons, hang on, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. You know what? I should look at these because I think there's fewer of those than there are descriptors. I won't use every possible answer. Atomic mass. That one there, the mass of the average atom of an element. Noble gases. The family of chemically unreactive gases. That helped because they both had gases in the same... atomic number. Hey, that's the number of protons in an atom. B. Bohr model. I think H. The reason I know it's not E, remember the raisin bun? That was the plum pudding, or that was Thomson's. That's what they thought at one point. Bohr came along and said, actually, no. I can tell you not only what's going on in the nucleus, but I can tell you the electrons are arranged in shells. Fancy word. Used to say orbits. A metalloid. Oh, D. Properties of both a metal and a non-metal. C says contain the element fluorine. I think those are called the fluoroids. Fluoride contains fluorine, like in your toothbrush. And E is the plum pudding model, which we don't care about anymore because it's not accurate. So, FGBHDA. FGBHDA. All right. Any 4 pieces of information on the periodic table besides the name? Call them out. What'd you say? Mass. I'll give you 1 mark for that. By the way, 4 marks. Let's assume 1 mark for each. Chemical properties. Are those on the periodic table? I'll give you a half for that. They're sort of inferred from the periodic table. Anything else? How about, which is the same as the atomic number? Oh, how about when it's neutral? Oh, and even when it's an ion, you can figure it out by counting over to the right or to the left. Oh, you can calculate the number of neutrons. It's there. It's just not blatant, but I got to do a little bit of math. What else? You've actually you've received a simplified periodic table. You'll see if you take Chem 12, they'll actually give you more specific. They'll talk about what type of shells there are. There's something called S shells and P shells and one other one that I can't remember. And they all have different properties and slightly. We're not going to get that high tech. Anyways, 4 of those, any 4 of those give you 4 marks. Anybody, anything else? We said symbol, average mass, atomic mass. Yeah, I think that's good. Sodium's atomic number 11. Draw a simple Bohr diagram showing the number of electrons in each energy level of a sodium. Okay. I suck at these, so I'm going to cheat. Nucleus. Copy. Paste. One shell. Oh, that worked great. Copy. Paste. I can't draw circles to save my life. 2 shells. And then I'm going to go copy. Okay. Oh, you know what I'm going to do? I'm going to go last. So, copy. Turn the little lasso thing off. Dope. Okay. Copy. Paste. Whoop. I think I told someone in this class I'm willing to spend an hour of typing to avoid 5 seconds of drawing because I suck at it so much. Okay, there we go. In the nucleus, now you could either put it in the nucleus or you could write it off to the side. I don't care which. But protons is 11. How many neutrons? 12? You can put P plus and N 0, or if you just put a P and an N, a clue in what you mean, because, you know, we're chemical nerds now. And then in the first shell, there is 2. Oh, you're going to have to do another big circle, Mr. Dewick. In the second shell, there is 1, 2, 3, 4, 5, 6, 7, 8. And then in the third shell, kind of like that, there is 1. So for 3 marks, I would give you 1.5 marks for each one of these. So I would give you half mark for the nucleus, right? A half mark for having one electron in your outer shell, and then a half mark for having the two inner shells filled in. Pardon me? Okay. If you got it right, you get 1.5 out of 1.5. But if you made a mistake, that's how I would give out part marks. By the way, do you notice I didn't add the extra circle to the ion? Why is that? Oh, watch and learn. Still has 11 protons, still has 12 neutrons, still has 2 electrons on the innermost shell, still has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its next valence shell. But what did it do with that 1 electron in the third shell? So I didn't even bother putting the circle in. Now, to show the marker that I did this on purpose, I say it's an ion. I've got my eye on you. Okay.
Could we also put +1?
Yep. But that's extra writing. You'll rarely see me do extra writing. Hopefully you've noticed I tend to abbreviate, right? This is also out of 1.5. Same as before, I would give you a half mark if you had done the nucleus correct. 11 protons and 12 neutrons. I would give you a half mark if you had left the outer shell blank. And this time, though, I would give you a half mark for the brackets and the plus. If you missed that, take a half mark off. What is a valence electron? What'd you say? I'll give you a hint. An electron in the outer shell. If you said something like that, that's great. Okay. Fancy word, valence. Makes you sound a little more nerdy, and we can all stand to sound a little more nerdy. How are valence electrons related to chemical families? Yeah. That's why we arrange them in those columns. Each family has same number of valence. You know what? I could have abbreviated electron up here too. Okay. Now, when Mendeleev first made up his periodic table, he didn't know that's why they went in those columns. He said because they have similar chemical properties. We now know, Jaden, the reason they have similar chemical... Jaden? Yeah, I was right. The reason we have similar chemical properties is because they bond with the same chemicals. And the reason they bond with the same chemicals, you're going to learn, is because they have the same valence electrons. Do nonmetals tend to gain or lose electrons? One word. Nonmetals gain. Metals lose, which is why metals conduct electricity so well, because all electricity is electrons. It's why it's called electricity. Turn the page. Oxygen ion. Okay. Just to show you how bad it could be, I will freehand this. Nucleus. Oxygen has 8 protons, and I think it has 8 neutrons, yeah? Okay. Then we have our first shell. I know that has 2. Then we have our second shell. Oh, shut up. I know it has 1, 2, 3, 4, 5, 6. Now, if they had said draw an oxygen atom, this is where I would stop. Did they say draw an oxygen atom? They said draw an ion. So somehow, probably from a couple of metals that wanted to get rid of electrons, oxygen, I'll change colors just so you can see, picked up an electron from a metal and an electron from a metal, and then, oh yeah, 2 minus. I'll live with that, but for some reason in chemistry, they write the magnitude, then whether it's positive or negative. I think I know why. What a chemical nerd would say is 2 extra electrons. 2 plus 2 fewer electrons instead of, but I'll take it. 2 marks each. I would probably go something like this. So if you got it right, 2 out of 2. Otherwise, I'd probably give you a half mark for the nucleus. I would probably give you a half mark for having 1, 2 shells completely full. I'd give you a half mark for the square brackets and a half mark for the ion charge, something like that. Argon. Okay. Really, Duick? Yeah. Okay. Nucleus. Argon is it element 18? Yeah, so it's got 18 protons. How many neutrons does it have? 22, thank you. And argon is in row 1, 2, 3, period 1, 2, 3. So it's going to have, you know what, change colors, Mr. Duick. It's going to have 1, 2, 3 shells. I'm making it big so you guys can see it. And because I suck, yeah. First electron shell has 2. Second electron shell, 1, 2, 3, 4, 5, 6, 7, 8. Third electron shell, it's also going to have 1, 2, 3, 4, pair. By the way, can argon ever be an ion?
No.
So never going to have square brackets around helium or neon or argon or krypton or radon or the one that I missed, which is xenon. That's right. Same thing. I would give you half mark for the nucleus. I'd probably give you a half mark for 1, 2, 3 shells, getting the period right. Half mark for a full outer shell, and a half mark because I like you. What if you don't like me? Well, then you don't get the half mark. No. Yeah, Cole, talking to you. Examine the rows. By the way, just to help you realize, if you want to, you could cross out rows and you could say periods. That settles some debate that was going on here, I think, earlier. Okay? As the rows, as the periods increase, what happens to the number of electron shells? Increase. More of them. If you really wanted to make me increase by 1, that would really make me happy because you not only said they increase. I know that each period adds in 1 electron shell, not 2, not 1 more. How many electrons are there in the valence shell of a sulfur atom? 1, 2, 3, 4, 5, 6? I counted over. By the way, you've probably noticed, although I count over, hopefully you picked up there are some shortcuts. You could subtract from 8 or whatever, and that's fine. Figure out shortcuts on your own, but I'm going to say Sesame Street is brought to us by the number 6. How many electron shells would I expect to find? 3? Yes? Last question? Yeah, last question. I like number 24, I like number 24, I like number 24. Number 24 is a nice question. Why would I say that? Did you hear me say that? Or your kind of student tends to notice when a teacher tends to emphasize certain things? Okay. See, this time I gave you the ion charge, which does make an extra step of thinking. I can't just read directly from the periodic table. I'm going to have to do some thinking. So, Mg, magnesium. Atomic number is magnesium 12? Yeah. Ooh, that was a guess. Ion charge is 0. What that means is it's an atom. It's neutral, so it's an atom. I'm just going to put A for atom. What would be a good letter to use for ion? Okay. So how many protons? 12. How many electrons? 12. How many neutrons? I didn't ask for that because you guys are good at that. Atomic number 8. Oxygen. This one is an ion. In fact, it has an ion charge of -2. It's an ion. It still has 8 protons. But because it's an ion, it's filled its valence shell. How many electrons does it have? Yes. Nice catch. How do I know when it's an atom or an ion? I'll have to tell you. At this stage in your young chemistry careers, in each question, I'll tell you. If I don't say specifically, assume it's an atom. In other words, if on the test I say, how many electrons does phosphorus have? It's an atom. If I say, how many electrons does a phosphorus ion have? That's when it's an ion. 19 protons. That means element number 19. Okay. Potassium. Atom or ion? Well, it's got an ion charge. of positive 1. So does it have 19 electrons? No, no. 18. It lost one. I think the two toughest ones were these last two. So the number of electrons is 18. Oh, that's element number 18, Mr. Duke. Actually, no. It became an 18 by gaining 2 electrons. So it must have originally had 16 electrons and 16 protons, an atomic number of 16. It must originally have been sulfur? And it's an ion. What's the charge of the last one? 0. It's an atom. What that means is the number of protons and number of electrons is the same. So if it's got 4 electrons, it's got 4 protons. It's got an atomic number of 4. It's after lithium. Beryllium? Is beryllium? Yeah, beryllium. Half mark for each of those. So this question is out of 1, 2, 3, 4 times 1, 2, 3, 4, 5. I think this question is out of a total of 20, yeah? Oh, but it's a half mark each. Thank you, Trevor, for correcting the teacher. It's always good to see when I make mistakes. It's out of 10. Give yourself a lovely score at the top out of 45, please.